Welcome! In this video we will take a first look at some reasons for using hybrid electric powertrains and also see how stricter fuel consumption standards are likely to lead to more and more hybridization and electrification. Then we will discuss how a cost-benefit balance can help us understand why hybrid powertrains need to be differently designed for different vehicles and for different buyers. For many countries in the world, there are at least 3 reasons to reduce fuel consumption of cars. One is to reduce CO2 emissions, another is to reduce the reliance on importing oil, and a third is to save money for the owner. All these reasons play some part in the development toward more fuel-efficient vehicles. Which of these is the main driver has changed with time and also differ between different markets. The 2 first often lead to states defining standards for maximum fuel consumption of new cars and to tax fuels. A hybrid powertrain is rather expensive and is therefore not the first option when aiming to reduce fuel consumption. Hybridization typically is considered only when several of the simpler ways of reducing fuel consumption have already been implemented, or when the fuel consumption has to be drastically reduced. There are many ways which have been used to reduce fuel consumption, like more aerodynamic vehicles, tires with lower rolling resistance, engine types with higher efficiency, and more gears. There are also some other possible ways to reduce fuel consumption, like less performance and smaller cars, but that goes against what most customers prefer, so the trend has instead been that performance has increased and cars have grown in size. The main way in which hybrid powertrains can save fuel compared to conventional powertrains are turning the engine off at standstill, which eliminates the idle fuel consumption. This can be achieved also in non-hybrid powertrains, but the higher electric power of the hybrid allows a much quicker engine start than in a non-hybrid powertrain. Recuperating brake energy also saves fuel, since the energy is used later during the trip to reduce the power demand on the combustion engine. Turning the engine off when the vehicle is driving and the power demand is low or zero will also eliminate idle fuel consumption of the engine. The fuel consumption can also be reduced by altering which operating point the engine uses. This can be achieved by a modified gear shifting strategy and by the electric machine adding or subtracting power to the combustion engine. Hybrid powertrain can also improve performance, since the electric motor can add power to what the engine provides, and also because it can provide traction power much quicker than the combustion engine can. An important step to reduce fuel consumption and tailpipe CO2 emissions is also to allow the vehicle to drive on electric energy from the grid, which is stored in a battery on the vehicle. A plug-in hybrid powertrain may often provide a cheaper way to do this than what a fully electric vehicle may. The best powertrain choice depends on many factors, and therefore there is not one single type of hybrid powertrain, but rather there are some different categories of hybrid powertrains, depending on what is the main driver for hybridization, but also depending on what type of driving cycle a vehicle is used in. In this diagram, we can see how the average fuel consumption of light-duty vehicles have been reduced significantly in different countries since year 2000, and how planned stricter fuel consumption standards are expected to continue to bring down the fuel consumption in the future. The diagram has 2 vertical scales. To the left is the average CO2 emissions per kilometer on the NEDC test cycle. To the right is the equivalent fuel consumption of a gasoline engine car in liter per 100 kilometer. Since the amount of CO2 generated by 1 liter of gasoline is a constant, the CO2 emissions are proportional to the fuel consumption. So far, many different methods have been implemented to make the powertrain more efficient. These include changing gear ratios and adding gear shift indicators to encourage drivers to use higher gears, developing more efficient types of automatic transmissions, reducing engine cylinder volume and adding turbocharger to reduce fuel consumption while maintaining the engine power, using diesel engines in many cars, stopping the engine at standstill. These efforts have reduced fuel consumption significantly. To date, quite a small portion of the reduction of average fuel consumptions comes directly from hybrid or electric vehicles. Despite making up only a small fraction of the cars, the hybrid can still be said to have contributed much to this development, since they have raised the bar by showing that a vehicle can be so more fuel efficient. This has helped to spur development also of the other ways of reducing fuel consumption. At the same time, vehicles have changed in ways which increase fuel consumption. Big-sized and heavy cars have gained popularity with increased performance. Of course, this tends to increase fuel consumption. However, all in all, the net development has been a significant reduction in average fuel consumption for light-duty vehicles. Despite the successful reduction of fuel consumption, there is a need to do even better. The general pressure to reduce CO2 emissions is increasing, and stricter legal requirements are likely to be implemented on many markets. In the EU, a fleet average limit of 75 grams CO2 per kilometer has been discussed. It is clear that long-term political goal in many countries is to fully eliminate CO2 emissions from vehicles. In the markets with the lowest fuel consumption, the most cost-effective and simple ways of reducing fuel consumption has now been largely exhausted. If the development should continue, hybridization and also electric vehicles are probably two of the more important remaining ways. To be able to reduce fuel consumption below today's state-of-the-art level, high-performing cars and bigger premium cars typically require hybridization. Note that each car model does not need to reach the limits, as it is the fleet average which shall meet a certain fuel consumption limit. Despite this, there is still pressure also on the premium cars, since many of their buyers expect them to be best in class, also on fuel consumption. At a little lower fuel consumption level, there is also a need to hybridize many of the more common mid-size cars. Eventually, there is a limit at which it's difficult to reduce the fuel consumption further by only more and more hybridized powertrain. To reach further, the source of the energy has to be changed instead. This can be solved by switching to electric propulsion, using battery electric vehicles. If run on renewable electricity, they have the potential to almost fully eliminate the CO2 emissions from the energy used. But battery electric vehicles are very expensive, and initially they also suffer from the limited charging infrastructure. Therefore, a cost-effective first step to further reduce the fuel consumption will often be to make plug-in hybrids. These will take a significant part of their energy from the electric grid when charging their batteries. Technically, a plug-in hybrid can be sized such that it can eliminate fuel consumption almost completely, but this is often not likely from a cost-benefit perspective. Instead, if really low fuel consumptions shall be reached without having access to public charging infrastructure, a more likely solution is a battery electric vehicle with range extender. Note that the different limits indicated in this figure are not at all exact limits, but only aim to show that there are steps in which harder and harder fuel consumption standards are expected to push for more and more hybridization and electrification of powertrains. Reduced CO2 emissions can also be achieved by using biofuel or hydrogen. Also, changes in transport mode, like a shift to public transport and more walking and biking, are viable options to achieve a reduction in total fuel consumption. In this course, we will focus only on hybrid electric powertrains, and to date, they also seem to be the main way forward for the nearest future. But of course, this will happen concurrently to other solutions. Since there are so many different types of powertrains with more or less electrification, we need to compare them to determine which is the best solution. The comparison includes many factors which may be valued differently by different buyers, and the advantages of hybrid powertrains may also depend on how the vehicle is driven. This is the reason why there is not one single simple answer to what is the best powertrain. We can analyze the alternatives by comparing according to a cost-benefit balance, symbolically illustrated by a teeter. Now we will shortly present some of the main factors influencing which powertrain can be suitable for which vehicle and which user. Here we focus only on the changes between a hybridized powertrain and a base vehicle with a conventional powertrain. Some of the possible benefits of hybrid powertrains are fuel savings, improved performance, and for some buyers also high status. On the other side, the hybrid powertrain will bring additional cost. To stimulate the reduction of fuel consumption, some governments also introduce incentives for those who buy fuel-efficient vehicles, like subsidies and free parking for electric vehicles, and they add to the benefits of the hybrids. We must realize that this analysis is a very complex one, since a powertrain can be hybridized to different degrees, which influence the cost of the powertrain, but also how much fuel it saves and its performance. Additionally, different buyers value exactly the same fuel saving, performance and status very differently. All in all, this leads to several different types of hybrid powertrains to fit different vehicle specs and ultimately meet the different customer preferences. So, in conclusion, the target of hybridization should not be only to minimize the fuel consumption, but also to find ways of hybridizing which provides several types of benefits at a low additional cost. And remember that what is a good hybridization depends on who is the buyer of the vehicle and how they will use it. Very good. I hope that you now have a better understanding why stricter fuel consumption standards are likely to lead to an increased portion of hybrid powertrains, and that there are several advantages of hybrid powertrains which should be taken into account. What powertrain buyers will prefer is a matter of the balance between additional cost and several types of benefits. This balance is to a high degree an individual preference. Thank you for watching.